So if you guys have some questions from homework 5, or if you have questions from earlier things too, let's take a few minutes and work on, or take some of those, and then we'll kind of get started on moving forward. Yes, Megan.
So I feel like 5 and 6 are probably the 2 of the harder ones.
Sure. Yeah, that's fine. Ken, is it my pick?
Maybe 6.
Good, that's the one I wanted to pick. Okay. So I ask you guys to do several things in the directions here. And when I look at this homework, I am going to be picky to make sure that you've done or followed the directions. So just rereading those, it says factor the given polynomial. You must include the number of solutions, the possible rational solutions, the likely rational solutions from looking at the graph, all synthetic divisions done in any factoring tree steps. So this should have 5 solutions because the degree is 5. The possible rational solutions are going to be what I get from the rational roots theorem. So the factors of 8 divide by the factors of 1. Can you stop talking, please? That's going to be 1, 2, 4, and 8. And then we're going to go ahead and look at the graph. So I'll just type this in exactly as it appears on my sheet of paper. Meg, are you still good with what I've done so far? Okay. Again, if you guys can stop talking while I'm talking, that would be nice. Thank you. That doesn't just mean continue talking quieter. That just really means kind of stop talking and try to pay attention. Thank you. So that's all typed in. I'm going to set my window to go from -8 to +8 because those are the biggest and smallest numbers on my list here. I'll hit graph. And I'll kind of wait for this calculator to do its thing. So if I look, it looks like there's something going on here, but it's a really long time from -1 to -2 that it's spending on the x-axis, and I can't really tell, like, is it crossing 1 time, 2 time, 3 time, like what's going on in there? So I'm going to zoom in and take a closer look because I'm a little bit curious about what's going on there. So I'm going to reset my window from like -2.5 to -0.5. And I'm going to reset the y's so that it's like quite small, so I get a really good close look, because it looks pretty flat against the x-axis there, which I know it can't actually be doing. So I'm going to set my y's from like -0.1 to +0.1. I'm going to take a huge zoom in there and take another look there. Okay. So it looks like I have something going on here at -2 and then something going on here. It looks like there was actually 2 x-intercepts there that were kind of hiding together as one thing. You kind of see that, Megan? Okay. And you saw why I was suspicious about this spot and wanted a closer look. Did it make sense as to what I was seeing when I was looking at the zoomed out portion to go, that looks suspicious. Better take a closer look because that might be more than one thing there. Okay. Now, both of these appear on my list, so I believe both of these 2 things are rational, so I can use either one of them to do the synthetic divisions. So let's just pick one of them to try, although I'm a little wary here because, well, I have a degree 5 polynomial, and I only have like I should have 5 solutions, but I only see 2 things I can use to do my synthetic divisions with. So that's maybe going to be a problem later, but we'll just kind of cross that bridge when we come to it, kind of thing. You see what I'm saying though, Megan? Okay. So normally, or for many of these, we had been seeing, like the same number of x-intercepts as solutions, and everything had been looking quite good. So there's that. And I'm going to go ahead and do my other synthetic division with the -2 right away here. Because the piece that I'm left with is 5 terms still, and I know I don't have any factoring technique to deal with that. So I'm just going to go ahead and keep on trucking here. And that works. So let's take, and then I have the x plus 2 that I'm getting from the second synthetic division. And then I have this x cubed plus 5x squared plus 8x plus 4 that I've left over after the second synthetic division. I'm still working on this one, Hallie. I don't know if you're asking a question about this particular problem. Okay, go ahead.
I got the same answer, I think. Maybe not. Like, I did.
You trailed off at the end.
Like, I didn't do this, but like I didn't solve it like that.
Okay, so what the directions ask you to do.
Yeah. That is.
Okay. Okay, so maybe at the end of class we'll come up and talk to me and show me what you did, and we can take a look at what's going on. Okay. This sounds like a very this is what my work looks like question, which I can't really answer without seeing it. You know what I mean?
Yeah.
So that probably is a better one-on-one question than a stop in the middle of, in the middle of the problem question. Not that I'm not happy to answer that. I just think that, you know what I mean?
Yeah.
Okay. All right. So if I look at this 4-term polynomial that's left here, this x cubed plus 5x squared plus 8x plus 4, that would be something I'd have to use grouping on, right? Now, can you look at that and tell if it's groupable or not?
I tried.
Okay, so you did try to group it and it does not work, which is what I would say. Again, you should be able to see pretty easily that there's not, after you take your GCFs out, what the leftover parts aren't going to match, right? Good. So what could we possibly do here? So there should be still 3 more solutions, right? Possibly 3 more things I could factor. We have a couple of choices. So that x cubed plus 5x squared plus 8x plus 4 thing, it could just not be factorable. That could be. It could have irrational factors that we can't use a synthetic division on, but we should have still seen those x-intercepts when we looked at the graph. So that seems unlikely. It could have imaginary solutions, which again are the pieces that are not factorable. Or it could have one or both of the -1 and -2 could be used more than once, right? That's something that can happen. So what I would do here is I would just, let's see if maybe one of those 2 solutions works again. Because they could be used more than one time. That's possible. Remember in last chapter we'd solve things and occasionally get the same answer twice? You remember that happening every once in a while in chapter 4? That could happen here as well. Like one of these answers might be used more than once. So we can try using -1 or -2 again and see if that works. So that, like do another synthetic division with -1 or -2. So let's just try one. And that did work, right? So we have this extra x plus 1 now from that additional synthetic division. And my leftovers, x squared plus 4x plus 4, that's something that we can factor, right? That looks like a chapter 4 factoring problem. What multiplies to give us 4 and adds to give us 4? 2 and 2. So that's our fully factored form. Now, when I write this, I would probably write it this way, just because it's shorter. But either way of doing it is fine. You can write it where everything's expanded out, or you can write it in that exponential form. Either is fine. I'm just letting you know that there's another way you could write that. So if you see some of my work and I do that, or an answer key that I write and I do that, you're not like, what the devil is that? That it means the same thing. Now, would it be nice if there's a way to look at this problem at the beginning and know that maybe I'd have to use some of these things more than once? That would be useful, right? If there's a way to predict whether we're going to have to do, whether we could do a synthetic division more than once with the same number. Well, it turns out there's a way to predict that. That's something we'll cover today in the lecture. So that is coming. That's really nice, right? Or maybe not. Maybe you don't think that's nice. Yeah. I think it's nice. I think that's very helpful if you're able to predict when that's going to happen or not. Megan, does that feel a bit better? Yeah, so again, the idea here, when we're doing these synthetic, or trying to do these factorings and using the synthetic division to do the factoring, is we want to, in the beginning, really figure out what's going to work and what's not going to work before we start doing the synthetic divisions. And all these little theorems and definitions and things we've addressed along the way are kind of adding to that information so that before we even start doing the divisions, we really have a pretty decent idea of what's going to happen. We might not know exactly how many times the synthetic divisions are going to work, but we'll know if we can do it more than once. And we'll even be able to say a little bit better than that in terms of how many times we might be able to do it. We won't know for sure, but we'll be like, okay, it's either going to look like it's going to be used this many times or this many times or this many times. And there might be a couple of different options, but we'll know, okay, it couldn't be done more than this. And it couldn't be done less than this or something. You'll have a good idea. Other questions from this assignment? Happy to do more? Hallie? 3. I'd be happy to do number 3. You're welcome. Okay. So we'll start by observing that I should be seeing 4 solutions to this because it's a degree 4 polynomial. And my list of 24 divided by the factors of 1. So since factors of 1 don't really matter, it's really just the factors of 24. 12, 24. Okay. And then we'll go look at our graph to figure out which one of these are rational or irrational. We can really kind of tell that from looking at just the picture. And in fact, we'll be able to tell more than that even just by looking at the picture, but that's coming in this lesson. We'll be able to get some more information even than that, which is pretty nice, right? This is a complicated enough process. As much as we can kind of eliminate or figure out what's going to happen before we start having to deal with it is kind of the better. I call all that stuff the pre-processing. If you can eliminate a bunch of stuff that can happen, so you really have a good idea of what to do, that really makes an enormous difference. So I typed in my polynomial, and now I'm going to set my window. I'm going to set it from negative 24 to positive 24, because those are the biggest and smallest numbers on my list. And I'm going to reset my y window back to negative 3 and positive 3 that I was using before. I don't want the super crazy zoomed in one that I was using earlier. And then I'm going to take a look at the graph. Now, I figure I'll probably have to zoom in again because I didn't think that really negative 24 and positive 24 were going to be that useful, but I wanted to make sure I didn't miss anything. So like all of this mumbo jumbo out here I can cut out, and all that mumbo jumbo there I can cut out. Really all I want to be able to see is this. If I were to estimate, looks like maybe -5 to +7 or something would be a decent window. I'm just trying to take an eyeball at it. I don't know exactly. I didn't count exactly or try to count exactly what those were. I just wanted to be close enough to where I could see what was going on. And that looks pretty good to me. Hallie, you still good with what I've done there? That doesn't sound reassuring. Should we stop and do I need to slow down and let you? I'm happy to slow down and do some more, or like clarify any of this if I lost you there. This is your question, so I definitely want it to be productive for you. Okay. So we have this part, right? Notice that all of these values are on my list up above, right? So these are all rational solutions and should be good ones to use the synthetic division on. Shouldn't really matter which one I use. So I'm just going to start with negative my synthetic division. So that one works, right, as I expected it to. And I have 4 terms there. I could stop here and try to factor by grouping, but I have 3 more synthetic divisions I could possibly do that I have a pretty good feeling are going to work. Why bother stopping here? Let's just go ahead and do another synthetic division. It's pretty fast to do. And that worked again. Now I'd be left with a 3-term polynomial, and that's pretty easy to factor. So I'm going to exit here the x plus 1 from the second synthetic division, and then x squared minus 7x plus 12 from my leftover pieces is something that I can factor, right? That looks like a chapter 4 factoring problem. So adds the opposite that were on my list of things to try synthetic divisions with, right? So this one, much clearer as kind of what was going on. You had to do more than one synthetic division to get to this spot, but there were 4 factors that you would have identified on the graph to use your synthetic divisions with. Those are the same 4 factors you should have ended up with. This one should have felt not too surprising. And Hallie, just as speaking to the work, it is my expectation that you are doing things kind of this way. I know that there's like a lot of these math photo apps that I've seen the work from, because a lot of you guys have submitted work in your homework using them that are just like not at all what I'm looking for and end up at the right answer. I'm going to be a bit more picky about that this semester than I was last semester. It's fine to use those things to like figure out like what's going on and whether things are right or wrong that you've done. No big deal there, not at all. But like if the work doesn't make sense to you and you can't replicate a whole lot of value other than you got a homework assignment done, and I'm happy to come in the next day and talk about homeworks in class and like do the problems just like we're doing them now. You know, and like if you don't finish stuff on time, just let me know. And like if you need ask some questions and turn some stuff in later, like that's not a big deal. So it's the calculator part that really gets you. Okay. So do you know where to put something in your calculator to make a graph? Okay, so you start by just pressing the y equals button up in the upper left-hand corner. And anything that's there in that y equals hanging around, just get rid of it all, so clear it all out of there. And then you're just going to type in the problem into the first space exactly as it looks. So I typed in 4x to the third minus 7x squared plus 22x plus 24, just exactly as it looks on the sheet of paper. So I didn't do anything there. Is that okay, Hallie? Do you know how to get all the symbols to show up for all? Okay. Again, I'm not trying to act like you're dumb. I'm just trying to make sure it is. Okay, so before I hit graph, eventually I want to look at the graph. But before I hit graph, I want to set my window so that I know I'm looking at the part of the graph that I really care about. Okay? So the part of the graph I care about is the part that happens... I'm sorry, let me rephrase. The part of the graph that I care about is the x-intercepts between negative 24 and positive 24. Okay? Because those are the things that I could use to do the synthetic division with, are the numbers between, are the rational numbers between negative 24 and positive 24. So what I did next is I pressed the window button. X-max control like how wide your graph is, like how far to the left it goes and then how far to the right it goes. So initially I set the x-min at negative 24 and the x-max at positive 24. And the y-min and y-max I almost always are just going to leave at like negative 3 and positive 3. It doesn't really matter, but those are the two numbers that I use almost always. And then I hit graph. And I got a picture that I could see the x-intercepts that I care about because there's so many tick marks down here on the x-axis. It was going to be kind of hard to read exactly what those numbers were, right? Because you see it crossing the x-axis here. You see that? So what I did is I said, okay, well, I better change my window a little bit. I found out the only x-intercepts I care about are these ones. There's nothing else out by negative 24, positive 24 that I care about. So I just said, well, that looks like it looks like stuff a little bit bigger than negative 5, and that looks like stuff a little bit less than positive 7. I just kind of eyeballed it. So I just went back and changed my window to negative 7 or negative 5 and positive 7. Again, those numbers are pretty arbitrary. I'm just kind of guessing at that, like, okay, most of this area that I've graphed I don't need because all I care about are where the x-intercepts are. And then I went back and hit graph again, and I have a picture that's a lot easier for me to read what's going on. So again, I'm looking at x-intercepts. That was negative 2. So that's where I'm getting the numbers from and how I'm using my calculator to do that. You're welcome. Okay. Anybody else? Yes, sir. 4? Okie doke. Let's see what. Okay. My list. My computer wants to bother to run all these things at the same time, which it's really trying hard not to. Okay. And this. So I have x to the 4th. Okay, I'm finish typing this in because if I'm midway through and I try to stop, I'm going to do something dumb and type. I'm going to make it a bigger mess. Let's just do this.